Hello and welcome to Vascular Shunt Screencast. Now today's focus, as I've just said, is vascular shunt, but we've got it's working as a specific preparation for exercise at heat. So in year one, vascular shunt was covered, and I think it's really important just to revisit that before we have a look at the impact of exercising at heat. So if we have a look then quickly, just as a quick recapper, so starting off here, your first thing then, vascular system. When we think of the vascular system, we're thinking of blood being transported by blood vessels. Now it works within the cardiovascular system obviously, but particularly we're looking at how blood is transported using different types of blood vessels. Now you might straight away start to be able to think we use two specific types of blood vessels when talking about blood flow last year. So if we go on from there then, if we look at exercise at heat, which we'll look at on your next screencast, the key thing is like the vascular system is responsible, or blood vessels in the blood are responsible for cooling us down. Okay, and the way they do that, we'll have a look at in your next screencast. But it's really important that we have an understanding of vascular shunt with regard to exercise. Okay, before we have a look at the impact of how vascular system and vascular shunt actually is heavily responsible for cooling us down when we're exercising at heat and allowing us to perform. Okay, so let's go on then. So if we have a look at last year's specification, so redistribution of cardiac output during exercise of different intensities, that was what you had to learn last year, and these were the key things from the specification: vascular shunt mechanism, role of the vasomotor control center, role of arterioles, and role of precapillary sphincters. They were the things that were vital at specification referenced. So if we just have a quick recap on that then, before we actually do the stuff you fully got to learn, let's just have a quick reminder then. So what we've got then is, at rest, we have this kind of, let's consider ourselves, our conditions at rest. So first up then, if you consider this, you've got two key areas really you're looking at, or categories of areas I suppose you should say. So at rest we need to consider the organs of the body and the skeletal muscles. So there are two categories of areas that blood will be either going to or not going to. So we'll have a look at that. And now during rest, because we have no particular heavy demand on our skeletal muscles, the majority of our blood flow goes towards the organs. So if we have a look at this, we've got 80% of our blood flow is transported towards the organs, and our skeletal muscles, in contrast to that, only has 20%. So that is our start point. That is rest. That's when we're not exercising. Now, although that's not in the specification because it asks about the redistribution of cardiac output during exercise of different intensities, it's really important that we just get that in our head to start with. When you're sat down, when you're not doing any type of exercise, 80% is the blood is going to your brain, it's going to your heart, it's going to your kidneys. 20% only is going to skeletal muscles because you're not moving, or you're moving very little. Now, what we have to have an understanding of course, is what happens during exercise. So if we start off then, redistribution of blood flow during exercise, the key term here is vascular shunt. So if we have a kind of look down to here, during exercise then what changes? Well, first up, so the organs at the bottom, I'm sure you can see there's a switch now. So you see up here, there's a redistribution of blood flow because we're exercising. So now what happens is only 20% goes to the organs of the body, whereas 80% now goes to the skeletal muscles. Now I've only just put one skeletal muscle here, it could be any of the muscles depending on the exercise. If it's a bicep curl, 80% will be going there. If it was a cyclist, 80% might be going towards the kind of working muscles of the rectus femoris, or the quadricep area. So if we have a look then, if we look at this, so we've gone from being 80% of the organs, 20% of the skeletal muscles, now to a complete redistribution of 80% of that blood flow going to the skeletal muscles. What we have to understand then is why. In the most simplistic form that you will get a mark on the mark scheme in this type of question, you just have to be able to say that, 80% now goes to skeletal muscles because blood is redistributed to the working muscles because they need it the most, because they are the things that require it. They are the area of the body at that point that demands it, and blood is redistributed away from the organs because they need it less at that particular time. So that makes sense. If you start running, if you start doing a bicep curl, the blood's going to go where it needs to go, and it's going to not go where it doesn't need to go. So that will always get you a mark, and potentially two, if it asks you why there is a redistribution of blood flow during exercise. So it's really important you see that from 2 points of view. Now, that's the why. That's why there's a switch or a redistribution. That's why it switches from 80 to 20, 20 to 80. So now what we have to do is, if you remember this, how does our body allow us to redistribute that blood during exercise? So how then, if we start off here, the first thing that kicks it all off is kind of receptors. So we have receptors in our body, okay, and they detect changes when we start to exercise. If you remember, we have chemoreceptors that detect an increase in carbon dioxide. We have baroreceptors that detect an increase in blood pressure. Finally, we have proprioceptors that detect an increase in movement. Those three receptors, alongside other receptors, okay, they send information, okay? So they send information to our brain that will allow us to start to think about redistributing blood flow when we start exercising. So the key part of our brain that's responsible for redistributing blood flow is the vasomotor control center, and its specific responsibility is this, okay? It stimulates vascular shunt, okay? So that's this redistribution of blood flow via the vasodilation, the opening, the widening, and vasoconstriction, the narrowing or the closing of arterioles and precapillary sphincters. Now, obviously, what we have to understand is during exercise, okay, vascular shunt will take place. We've got to understand where the arterioles and precapillary sphincters will vasodilate towards, 80%, so to here, and where the arterioles and precapillary sphincters will vasoconstrict towards, where we don't want it to go, which would be here, okay, to the organs of the body, 20%. So if we have a look down to here then, our focus, vasodilation takes place of the arterioles and precapillary sphincters supplying the working muscles, the 80% of the blood going to those working muscles, so you can envision that, the precapillary sphincters and arterioles opening up, okay, getting bigger so we can get the 80% of that blood to the working muscles where they're needed, or where it's needed, sorry. And finally, we have this, so vasoconstriction. So vasoconstriction, okay, so the arterioles and precapillary sphincters, now supplying our organs of the body, they will need to close, so that there will be a closing of the arterioles and precapillary sphincters, so less blood goes there because it is not needed at that point. The demand is in the muscles. So I'll just put that onto there. So there's a vasoconstriction of arterioles, precapillary sphincters supplying the organs. Okay, so that gives you a kind of an overview of the process of vascular shunt or redistribution of blood flow during exercise. So if you remember from ASPE, we actually used an acronym to remember this. Well, as soon as you saw redistribution of blood flow, how does it happen? Remember, we used this concept of vast distribution. Okay, so if you remember there, receptors enter VCC. We talked about vascular shunt, vasodilation of the arterioles and precapillary sphincters supplying the tissues or working muscles. Now, on top of that, of course, you could talk about vasoconstriction of the arterioles and precapillary sphincters supplying the organs or the non-essential organs at that point. Okay, so I'll just check you now, make sure you feel confident on that. I think the difference really here is just to make sure from year one, it's just to make sure that you understand that kind of there's a vasodilation and vasoconstriction. Now, when we go to heat, we'll have a look at how the vascular system is responsible for helping us cool down. Okay, thank you very much.